In the grand theatre of intelligence, two protagonists take the stage. In one corner, the master of adaptation, the product of millions of years of evolution, the human brain. In the other, its digital apprentice, an innovation that is reshaping our world, the artificial neural network. Inspired by the brain, ANNs now power everything from medical diagnostics to speech recognition. But how deep does this resemblance truly run? Are we creating a mirror to our own minds, or something entirely different? Let's start with the blueprint. The brain operates on a network of billions of neurons, connected by trillions of synapses in a complex three-dimensional web. It's a dynamic living architecture where structure and function are in constant flux. Artificial networks are built from digital neurons or nodes, arranged in clean, organized layers. While inspired by the brain's topology, most ANNs have a more rigid structure. Information typically flows in one direction, from input to output, through a series of mathematical calculations. In contrast, the brain is a storm of recurrent feedback loops, with signals echoing throughout its structure, creating a far more complex and holistic processing system. The most profound difference emerges in how they learn. A human can learn a new concept from a single experience, an ability known as one-shot learning. We seamlessly integrate new knowledge while preserving what we've already learned. ANNs, on the other hand, require a brute force approach. They must be trained on vast datasets, often seeing the same information thousands of times through a process called backpropagation. Furthermore, when an ANN learns a new task, it's prone to what's called catastrophic forgetting. It can abruptly lose the knowledge it had previously acquired. The brain avoids this by employing a more efficient principle, configuring its connections to protect existing knowledge while integrating the new. This leads to the nature of memory itself. In an ANN, what it learns is hard-coded into the mathematical weights of its connections. The knowledge is permanent and precise, but also brittle. Damage to the network can corrupt the information irreversibly. In the brain, memory is thought to be a more volatile and distributed phenomenon. It isn't stored in a single location, but as a pattern of connections across the entire brain. This makes it incredibly robust. Damage to one area doesn't necessarily erase a memory. However, it's also less permanent, subject to fading and alteration over time. So, who is the victor? There is no contest. The brain remains the undisputed champion of general intelligence, efficiency, and adaptability. ANNs are not replicas of the brain, but rather powerful, specialized tools that excel at the specific tasks they are trained for. They are a testament to our ingenuity, but they also highlight the profound mystery and elegance of the biological mind. The future of AI may not be in perfectly mimicking the brain, but in continuing to draw inspiration from its principles to build a new class of intelligence, one that complements our own and pushes the boundaries of what's possible.